Hi, my name's Scott Davis. I live in Harper County, Maryland. A couple weeks ago, I put together a YouTube video on solar, and I gave a tour of some of the solar projects that we have here at the house. If you haven't seen that video already, I really encourage you to take a look. It covers a lot of neat information. Well, as a result of that video, I got a lot of questions specifically on how we built our solar hot air collector with aluminum downspouts. So here's a lot more information on how we put this together.
I'm actually going to describe two builds for you. The first is the collector that we built here, and it's followed up by another collector that another fellow also named Scott has built and really improved on the design that I came up with to begin with. So first, here's a segment from my Solar Collector 101 video on our solar hot air collector that summarizes the project, and then we'll get into a lot more construction detail.
Okay, behind me is our solar hot air collector. This collector is on the side of the house that faces towards the street and the neighbors, so I wanted to build something low profile that they really wouldn't notice, and this worked out perfectly. This collector is only 13 inches high and is 24 feet long. What I did is take aluminum downspouts, painted them black with Rust-Oleum flat black spray paint, and I'm simply taking air from our basement, running it down one end, and then back up the other, and then back down to the basement. Again, hot material, or black material, gets really hot under glazing, and we're taking advantage of that heat. This is truly a vertical orientation, so the efficiency of this collector actually improves as we get towards the coldest months of the year as well, when we have a nice low tracking sun. And I will show you inside what we've done with that as well. Okay, here we are inside our basement. This is the input and output for our solar hot air collector. This fan is running, which is pulling air off the basement up through our hot air downspout collector. It runs through the downspouts, circulates, and blows out back here at about 80 cubic feet per minute. So for hours on end, we've got nice hot air that's pouring out of this collector, fills up our basement, radiates up into the house and up through the stairway. Simply a fan. There's a snap switch in the collector which automatically turns the fan on and off when it gets over 110 degrees and fires it up, turns off automatically. So it's simple plug and play. Very easy, very inexpensive, and it does the job. It should last for decades.
The lumber used in this project is primarily 1x6s, pressure-treated lumber. We began by laying out the project in the garage. The back is laying on the floor with the bottom to the left. I cut one of the 1x6s in half so that the pieces would be staggered. And they were connected using 11-inch pieces of 1x4s. I don't have a picture of those here. 2-inch by 3-inch or 3-inch by 4-inch downspouts will work fine with this collector, although if you build a single pass like mine, go with the larger downspouts to get better airflow. The downspouts are connected to 4-inch round PVC by the adapters that were available at Home Depot. And being quite large, at 24 feet long, the collector wouldn't quite fit in the garage, so fortunately we had a really nice day. The spot where the airflow exits one downspout and enters the other is called a plenum. Now, I made mine out of 4-inch PVC and just cut notches with a jigsaw, but mine's really too restrictive and I'm sacrificing some airflow. Scott S. came up with a much better approach to do that, and I'll show you that in just a little bit. Once we had the frame all complete and all the parts measured out, my son Brad and I carried the 24-foot frame out to the windowsill and just set it right on top of those. It sits very sturdily there. It's not anchored in any other way, and it's been there over 2 years now and has been doing just fine. Don't let my sweaty appearance fool you. This is not hard. It was a very hot day that we were building this project. The downspouts are now inserted. We have them simply resting on pieces of insulation. And there's insulation behind the downspouts as well. In the basement, we have our fan, our inlet on the left, which pulls the coldest air off the bottom of the floor, and the outlet on the right. The unit turns off by a snap switch now. When this was taken, I originally had a differential controller, but there was no need for that when a $10 snap switch will do the job. I really wasn't having a problem with any backflow, but just to make sure, I put a backflow dampener in, which simply is a spring-loaded device. When the fan kicks on, the wings open up and out comes the nice hot air, and then it closes automatically when the fan shuts off. And here's our finished collector. It is painted flat black with Rust-Oleum spray paint, and it's covered with plexiglass UV stabilized glazing. And one of the best parts of this whole project was being able to do it with my son Brad. We really had a good time and a lot of fun putting this together. I am really happy with the results of this collector. It works very well. The performance is in the 50% range, which is on par with commercial collectors. That said, Scott Smith, who lives in the Finger Lakes region of New York, took my original design and really made some nice enhancements. And here's the collector that he put together. First of all, he built much bigger, 32.5 feet by 3 feet for 97.5 square feet of collector area. It's always a good idea to build as big as you can. He built with a 64-degree tilt angle to maximize the winter sun, and he has a much better plenum design for a much better airflow. My collector stays out all year, and that's worked out fine, but Scott designed his so he could take his apart and store it in the summertime. And here are his PVC inlet valves that are capped off for the summer months. In addition to being bigger, where Scott's design really excels is his use of the plenum. See how he designed his frame to allow a nice large airspace to let the air go down 3 aluminum downspouts in parallel and then come back the other 3 and return to the house. That allows for a much better airflow, not only the plenum itself, but because he's feeding the downspouts in parallel, he has a much less restrictive flow and a lot better airflow. And you really want as much air flowing through your collector as you can to harvest as much heat as possible. Note also that he's put a little space between each aluminum downspout, and he also used aluminum flashing behind to catch that heat and transfer it to the downspouts, and it's really shown up in his performance numbers. Here are Scott's stands for his collector and his original outlet that he placed in the basement. Now what Scott found was that he had so much heat in his collector that he needed 2 fans to pull that out efficiently. So he set his fans up in such a way that the first fan kicks on, and when the second fan senses enough heat being distributed from the first fan, it also kicks on. Scott is seeing over 150 degree Fahrenheit output with efficiency numbers in the 60s, which is just outstanding. I hope you enjoyed learning about our aluminum downspout hot air collector designs. If you have questions or you'd like to learn more about them, we'd love to have you join us on our email group, Simply Solar. Both Scott Smith and I are active participants on that group, and we would love to help you get started with your project.
Thanks so much for watching the video on our aluminum downspout hot air collector. I hope you enjoyed it. If you have more questions or want to learn more, please join us on our Simply Solar email group. I'd love to chat with you more about it. You have a great day.